Now let us understand how we can use the convolutional neural network to do the image classification. The convolutional neural network basically used for the image processing or image related image classification and so on. Okay, it's mainly for image related. Okay, image processing, the convolutional neural network. It is a special neural network specifically designed for processing the pixel data used for image recognition and processing. Okay. So what we will do is, as part of this, we will take a look at the history of convolutional neural networks and what, why, when, and how of convolutional neural network, the difference between ConNet and the plain neural network. We discussed already about multi-layer perceptron, okay, in the neural network. We'll understand the difference between these two. Why should we have to use convolutional neural network in place of multi-layer perceptron? That we will walk you through that as part of this one, and then we will understand the building blocks of your convolutional neural network, right? The convolutional neural network is composed of multiple building blocks. So the convolutional layer, pooling layer, normalization layer, and fully connected layer. And then we will understand the mechanics of convolutional layer and the entire convolutional neural network. Finally, we will take a look at how do we implement the convolutional neural network using TensorFlow, Keras, and PyTorch. PyTorch, I did not use it. We will take a look at that one also if time permits. So first of all, what is a convolutional neural network? It is a class of artificial neural network. This has become dominant in various computer vision tasks. As I said, even in the case of face recognition, the case of self-driving car, the convolutional neural network is used. This is part of, this falls under computer vision. The main objective of the convolution is to extract features from the input image. Right? Another advantage is it automatically detects the important features without any human intervention. This is also one of the differences between the machine learning and deep learning. In the case of deep learning, we need to do machine learning, we need to do the feature selection. But here we don't have to do the feature selection. It is done automatically by the deep learning algorithm. So again, the computer vision is also a subset of the deep learning. That's what I explained a while back. This is also another advantage of convolutional. It automatically detects the important features without any human intervention in an image. Okay, and and the main advantage of CNN is that it can successfully capture the spatial and temporal dependency in an image through the application of relevant filters. Okay, spatial and temporal. What is spatial and temporal? Spatial dependence means a pixel value is influenced by nearby pixels values in an image. This is because generally they all belong to same color because they are from same object. The temporal dependency comes in videos when a frame changes next. There is a lot of movement in objects, pixel values will remain the same. So we'll discuss about spatial dependency and temporal dependency a little later. The idea of when I explain about the difference between multi-layer perceptron and convolutional neural network, you'll be able to understand this one. Okay. So now remember this, with the help of CNN, we can extract the features from the input image. Let's say you have taken your photo. Okay, you are giving your photo as an input to the convolutional neural network model. So what it does is it goes and extract features from your photo. Okay. And in your photo, you have your face and also the background thing is there, right? It doesn't care about the background thing. So, all we need is whether it is a human or something else, right? Human or animal. We want to classify that. For that, we are using this one. In that case, what it does is it goes and looks, that's where the image localization comes into picture. Okay. And with the help of filters, we have something called filters. We use it as per the convolutional layer. In the case of convolutional neural network, the filters it is also called as a kernel. That is the one is helpful in terms of extracting the features that we are interested in, and then it automatically detect that's what I said, the important features without any human supervision. It's because of the filters. That's what the relevant filters. A lot of different types of filters are available. With that, it can filter it. Now the question is, what is the difference between the MLP, multi-layer perception, the typical neural network, and the convolutional neural network? The fully connected neural network don't work well on images. Why? When it comes to images, each pixel is an input. Okay, then as we include more layers, the amount of parameters increases exponentially. For supposing, let's say your photo, you have taken a photo. That photo, the width is 32 and height is 32. The photo width and height. Okay, so 32 cross 32 pixels are there, right? And if it is a color image, 32 cross 32 cross 3, 3 red, green, blue, right? You need to multiply by the channel also. This is your width of your image and height of your image. You need to multiply by this 3 because the color image or photo, have 3 channels in it. So when you multiply this, you get 3072 weights. Each pixel, in this case, 372 weights, 3072 neurons will be passed as an input. According to us, only one simple photo. But when it comes to neural network or convolutional neural network, it considers each and every pixel as a neuron. So 3072 neurons, it has to create, so 3072 neurons have to be created. Okay, and in the case of input layer, you have 3072, and in the hidden layer also, you need to have 3072, right? So in this case also, it is fine, but what if the image size is going to be 200 cross 200 cross 3? The width is 200, height is 200, and it is a color image. So if you multiply all the things, you will get 120K weights. So 120,000 neurons will be there in your input layer, and then your hidden layer, you have 120,000 neurons. Again, the subsequent, let's say if you are using, so we are talking about convolutional neural network, it is part of your deep learning algorithm. What is deep learning? Between the input and output layer, you will have multiple hidden layers will be there. More than one hidden layers will be there, multiple. So since the number of hidden layers are more between input and output layer, it is so deep. Hence, it's also called a deep learning. Okay, in the case of deep learning, between the input and output, you have multiple hidden layers are there. Remember this. But as part of neural network, I've shown you only one hidden layer. For the sake of simplicity, I've shown. But the typical neural network, it will not have multiple hidden layers. But when it comes to deep learning, you will be using multiple hidden layers. I'll explain why we have to use multiple hidden layers. Okay, but a little later. Okay, so not this moment. You just look at this number. So 120,000 neurons have to be created in your input layer. If you use a neural network, the typical neural plain vanilla neural network, the hidden layer also 120,000. If you are going to use more than one hidden layer, right? So if you multiply all the things, the number of parameters or the weights will get exploded like anything. Okay, so because of the presence of several such neurons, right, the fully connected neural network will have huge number of parameters which can quickly lead to overfitting. Hence, using the neural network is absolutely no use here. In the case of convolutional neural network, the neurons in a layer will only be connected to a small region of the layer before, Yeah, so this is another point. So in the case of neural network, right, so every neuron in each layer, right, is connected to every other neuron in the subsequent layers. You remember, this is what I discussed as well. See, neural network is a very important topic. This is your input layer. This is the input layer. Okay, this is your input layer. You have neuron, so 1, 2, 3. This is, let's say, age of a person, something else. Okay, and you have hidden layer. In the case of hidden layer, you have another neurons. So every neuron is connected to every other neuron in the case of the typical neural network. It's a overkill when it comes to this many number of image processing. So image processing, you already have 1 lakh. See, in this case, only 3. if you have 1,20,000 input neurons, and if that input neuron is connected to every other neuron in the subsequent layer, it's a overkill. It requires a lot of parameters that can also, so that can leads to overfitting, and at the same time the training time will become very, very high. Whereas in the case of convolutional network, the neurons in a layer will only be connected to a small region of the layer before, right? A small region of the layer before it, okay? Instead of all of the neurons in a fully connected manner. So instead of this one, right? So in the case of convolutional neural network, so maybe, this one will be connected to this one, and maybe, right, and this one will be connected to this one, and only this one, specific to this one. Not every neuron in the input layer is connected to every other neuron on the hidden layer. It is not happening this way. So in the case of convolutional, the final output layer will have dimensions like 1 cross 1 cross again. Anyhow, this one you might be wondering, so how come in the case of convolutional neural network, it is the neurons in a layer is connected to a small region of the layer. So what is happening here? How it is possible? That we will discuss it now. Okay. So look at here. This is what I was trying to say here. So in the case of typical neural network, every neuron in the input layer is connected to every other neuron in the subsequent layers. The multi-layered perceptron, all fully connected layers. Okay. But whereas in the case of this one, look here, these two inputs get connected to them. These two pixels, right? Only these two pixels got connected with this one, not every other neuron. In the case of convolutional neural network, with partially connected convolutional layer. So in that case, the number of weights will get reduced. Hence, the training time will be faster. And so the training time will be faster. And other important aspect of the convolutional, we are using the filters. With the help of the filters, we are extracting only the specific features, the key features from the image. The other difference, look at here. So look at these two images. In both the images, as a human, we can quickly say, these two images have dogs in it. But in this image, the dog is located here, whereas in this case, the dog is located on the right side. When it comes to neural network, the typical neural network, it goes by each and every neuron. Okay, so pixel, each and every pixel is nothing but neuron, right? Supposing 32 cross 32 cross 3, this is the width. Let's say the width of this one is 32, height is 32, and since the color, the three channels are 32 cross 3, so 3072 bytes. It has to go and create the neurons for each and every pixels. But in the case of convolutional network, what it does is location doesn't matter. But still, what happens? Neural network, it considers this one as a separate image. It considers this one as a separate image altogether. According to the neural network, these two are two different patterns. But when it comes to convolutional neural network, it goes and identifies the features. So look here in this case, okay, eyes, where it is located. Okay, and it goes and first identify the eyes and ears and the shape, it identifies it. Similarly, here it goes and checks. Okay, and here if it cannot find anything, it will not be, it will be ignored. Okay, just think that way. Okay, it goes and find out where that the curve is. See, the eyes are curved, right? The curve, the edges, where the curve and edges are there, based on which it will go and the filters. With the help of the filters, it can read the features from this image rather than considering these two as two different images. When it comes to convolutional neural, it consider these two images same pattern. These two images has same patterns in it according to convolutional neural network, because it goes by the features, where the curve is there, where the edge is there. Okay, so as you have multiple convolutional layer in your convolutional neural network, each and every layer will detect the different features on a piecemeal basis. Initially, it start with detecting this one, and then slowly, the simple analogy is, so let's you have a close friend, and you saw him in a mall, but he is coming far off from you. Okay, but he is standing far off from you, and he is coming towards you from that direction, but you are not able to detect him correctly. But with his walking style and the shape of him, right? You're able to some extent you can guess. As he come closer, you are able to make out very clearly, okay, he is my friend, he is so and so person. Something like that. As you have more conventional layer, the first layer will detect the curves and the lines, everything, and then the second layer will apply on that detected one, and then what it does is it tries to find out some other features in it. Okay, according to the conventional, that's what I said. These partial and temporal dependencies here. If you see here, this one and this one, right? There is a correlation here. This curve and here something is there, and if you little move here, right, this one and this one, so this curve and this curve has some correlation. So in the case of conventional, it goes by the correlation. Okay, the pixels wherever correlates, right, it goes by that, and then that is how it deducts the features from the images. Okay, so according to the conventional network, both the images are same. When it comes to neural network, it treats these two images two different things. But we know very well as a human, in both the images, all we need is what object is there in this image. That's all, right? So in that case, why it has to go through the um, pixels where we don't see any um, features here, right? Features, these are called features. If you don't see any features here, why it has to go here, right? Simply it can ignore this one. So in the case of convolution, it can learn. See, the neural network cannot learn the local patterns. Okay, and apply to those different areas of that image. It apply everything to different part of the image. Whereas in the case of convolution, it can learn the local patterns. Okay. This is the difference between the typical neural network and the conventional neural network. The regular three-layer neural network, you will find something like this: input layer, output layer, hidden layer, and this. Whereas in the case of conventional neural network, it arranges neuron in three dimensions. The one is width, height, and depth, as usual in one of the layers. Look here, this is your height, and this is your width, and this is your depth. This is your input layer, and we will see how it is working. So when I explain you the architecture on a piecemeal basis, you should be able to understand very clearly how the convolutional neural network, how the convolutional layer works. The important or the significant part of the convolutional neural network is the convolutional layer. So as you can see here, in the case of the typical neural network, you have the input layer and output layer. In between, you have hidden layer. Whereas in the case of convolutional network, the same thing, input and output layer is there. But here, followed by the input layer, you have the convolutional layer. Followed by the convolutional layer, you have the pooling layer. And then you will have the typical neural network. Even in this case, you will have the fully connected layer. So this is the one. But just before this, you have the convolutional layer and pooling layer. The combination of the convolutional and pooling layer, we are extracting only the features that are interest to us. Only that features will be sent to your fully connected layer. So in this case, what happens if the image size is 200 cross 200 cross 3? What will happen? You will have to create the model has to create 1,20,000 in the neurons in your input layer, and the hidden layer also you need to create. It has to create this many number of neurons. But what happens is, instead of using the neural network model directly, we have some preliminary step. As part of the preliminary step, we detect the features using the convolutional layer and pooling layer. With the help of with the combination of these two, so it detects only the features. Only these features will be sent to your neural network, the convolutional layer, roughly speaking. So in that case, what happens is your fully connected layer will receive only the features, the key features that are detected as part of as the combination of these two layers. So in that case, what will happen? The number of neurons will get reduced. So you just, instead of, literally going by 200 cross 3, if my conventional, the combination of my conventional net and pooling layer, if it detects only the features, only if that sends the features related neurons. Let's say the features related neurons comes instead of 200 cross 3, right? Let's say 50 cross 50 cross 52, let's say 32 cross 3. Let's assume that way, okay? So in that case, what will happen in the number of features will get reduced. You remember in the case of the supervised machine learning model, I explained about the feature selection technique. In your data set, you have 100 columns are there, features are there. But once you do the feature selection using RFE or some other technique, stepwise regression, and if that recommends to use out of 100 features is only 6 or 7 features. So in that case, what will happen? Your training time will be less, and then the accuracy will be good. Similarly, here also, the convolutional layer, with the help of the convolutional pooling layer, we are doing kind of feature selection in simple term. And then those selected features will be sent to your fully connected layer. Hence, the number of neurons that are required will get reduced substantially. The fully connected layer, what it does is, it does the classification upon receiving the matrix of, the pixels, right, from here. What it converts them via something called softmax activation function. The softmax activation function, what happens is, it converts your array of pixels into the probability thing. Okay. So now we'll take a look at what each layer is all about. So I just put the block diagram here, but this is how it will be like. Let's say you have an image. Okay, you want this image to be classified, whether it's a human or something else, okay, or female, male, or something else, okay. So in this case, what happens is, you have the convolutional layer. What it does is, in the convolutional layer, we have something called filter. The filter will be applied on top of the, or filter or kernel will be applied on top of your input image. And then it extracts, the filters or the one playing the crucial role in terms of extracting the features, the key features. So initially it extracts the edges here, okay, the edges, and okay, so it edges, lines, okay, and it learns the pattern. The first layer, the network tries to learn patterns and edges. In the second layer, what I'm seeing again, I have used another conventional layer and pooling layer. The second layer tries to understand the shape, color. So as the number of conventional layer and pooling layer, getting increased, when you have more number of conventional and pooling layer, what will happen is, it will have better, understanding about what is there in the image. So initially it tries to detect the edges, okay, curves and edges, and then it learns the patterns. And then the next conventional layer, what happens within this image, take this identified feature map. This is called feature maps. The conventional layer produce the feature maps, the output. Okay, the conventional layer, you have filter. The filter will be applied on your input image, and then the conventional layer will produce an output. So you have an input image here. The conventional layer, what it does is, it applies the filter on this one in order to extract the features from this. So we don't care about the background, right? So we need only the key features. In this case, it detects only this is called image localization. Okay, it goes and draws the line here, and it detects the curve here. Okay, here the curve is there, the edge. Okay, and then initially it comes. So as you have more number of, as this extracted features from the first conventional layer, right? What happens next one is the pooling layer. What it does is, it does something like downsampling. Okay, so that the number of pixels will get reduced further. Okay, so here 128 cross 128 cross 1, right? So with the help of conventional layer, we are able to reduce the pixel size to 126 cross 126. See, in this case, I don't need the color and all. All we need is whether it is a female or male or something else. In order to know female or male, if I have the black color, that is more than sufficient, right? So in that case, what will happen? The pixel size will get reduced automatically. So look here, this is not a colored one. And again, on top of this, when you apply the pooling layer, again, it tries to downsample this one, okay? It tries to reduce the pixel size. And then what happens is, again, the feature map size, the pixel size will get reduced. And then this one will get passed as an input to the subsequent conventional layer. Again, the conventional layer will apply the filter on the pooling layers output maps, feature maps. And then it tries to detect, again, the objects that are present in this one, and then again you do the pooling, like you keep do it one after in the subsequent conventional pooling layer. So what happens is, your pixel size will get reduced, number of the pixel size will get reduced, And then as you use multiple conventional layer, what will happen is it performs the complex pattern learning. So as the number of convolutional pool layer the increases, it detects more features in it, more the features. First it detects the edges, and second one it finds out the color of the thing, and then the other patterns, and finally it gets the better clarity. Okay, so this image has a female. Okay, she has the what do you say, the hairstyle tells, and again body shape tells, okay, it's a female, right? So it automatically detects each and every features in depth as you introduce more number of conventional and pooling layer. And finally, when it comes to this one, what happens is here it converts this multiple dimension of your arrays into a single dimension. That is what happening in the fully connected layer. Just before the fully connected, it is flattening this one, 30 cross 30 cross 4. And so before that, let's say in this case 4 cross 4 cross 4. What happens is it flattens this one, 4 cross 4. It will flatten this a single 1D array. And then this one will be sent to your fully connected layer. So hence, look here, we started with 128 cross 128 cross, but now you have just 4 cross 4 cross 4, right? So number of pixels got reduced, and finally you got something. So what happens, this one, the converted, the matrix, the matrix values got converted as a 1D. This is called flattening. Okay, convert your matrix into one-dimensional array, and then this one will be fed to your fully connected layer. Fully connected layer can identify, or it can do the classification with this reduction in the number of neurons. Okay, here. So hence the classification time will be pretty faster. So in the case of fully connected layer, we use something called softmax layer. In the case of output layer, what happens? It takes each and every pixel value, and then it converts as a probability. Okay, so for this, it says cat is 0.005, dog is whichever class has more probability. That means that this image falls into this category. If you look at all these categories, cat, dog, horse, and human probability is 0.70 compared to other category. Human, the probability assigned to the human category is 0.70. Hence, we are damn sure this image is human, not horse, dog, or cat. You understood? So up until this, it does the feature extraction. Okay, and then each layer produces the output. That is called your feature map. Each subsequent layers, the feature maps will be fed as an input to the subsequent layers. And then finally, when it comes to the fully connected layer, right? So what happens is it flattening the final feature maps produced by this pooling layer. And so if you see here, we started with this one, now we ended with this one, right? So the size got reduced, the number of pixels required got reduced here. This is how it works. So this is your feature extraction layer. This is your classification. Neural network is the typical neural network is your classification. The convolutional layer, this is where it extracts only the features. It does kind of feature selection, and then the selected features will be sent to your fully connected layer. Hence, the training time will be faster, and the fully connected layer produces the probabilistic output for each class, right? It assigns the probability for each and every class. Supposing you have 10 classes, each classes, it assigns the probability. Whichever class has higher probability, that one will be emitted. So in this case, it will say, hey, this is a human. Okay. So now we will take a look at each and every layer. What is input layer? One second, I'm just getting a call. So, okay, we'll start with the each and every layer. So what is input layer? All the input, so all the input layer does is, it is reading the image. That's all. You just feed the image. That's all. The convolutional layer, what it does is, it identify the patterns instead of going by individual pixels. It will not go by each and every pixels. It will identify the patterns, features. Okay, that is the beauty of convolutional layer. How it identifies the features? Using filters. Okay, the conventional local receptive field. So what is local receptive field? Whatever the field. Like I asked you, what is there in that image? Mala responded with saying that dog. That is a local receptive field. Though that image has some other objects like, just, behind the dog, or alongside the dog, we could see the grass. But our eyes, we have the visual cortex in our brain. It focuses only the objects that we are very much interested in. Right? The same principle is working, is used here also. Okay, so here what happens is instead of going by each and every pixel, it detects the features or patterns. Okay, so that is what is happening at a high level. The convolutional layer is the first layer to extract features from an input image. The role of the convolutional is reduce the images into a form which is easier to process. That is the whole idea of the convolutional layer. It helps us to do the feature selection or feature extraction. That's all. The layers are in 3 dimensions: height, width, and depth. Neurons in one layer do not connect to all the neurons in the next layer, but only to one small region of it. Look here, in this case, it detects only the pattern. Okay, this is X. Okay, here it says here also X, right? It goes and picks whether it's a X or something else. That's all. It goes and learns the pattern. It is not going. It is not necessarily each neuron in the input layer to be connected to the every other neuron in the subsequent layer. Small regions. So look at this one will be connected to only this one, and this one will be connected to this one. So how is it possible? With the help of the filter. I just directly jump into the filter. What exactly the filter is all about. Look here, this is what the image. Let's say they've given your photo. Let's take, for example, you are showing your photo to the conventional, your model, the conventional neural network model. The photo for your the image, right? The photo image of yours is, for that the corresponding pixel values are like this. It's a 3x3 size. The image width is 3 and height is 3. Let's assume that way. Okay? It's a grayscale. Grayscale is channel is 1. Remember that. For your photo, the corresponding pixel values are like this. 3x3 is, this is the one. So 3 rows and 3 columns. So 1172. What happens is here, this is called your filter. It is also called as a kernel. What happens is, in the case of convolutional layer, it applies this filter on top of your image. So the computer identifies the images in the form of pixel value, the numbers, right? The pixel values. Each pixel value ranges between 0 to 255. That is what I said. So we are applying the filter. So each filter has different meaning. This is something like, for example, let's assume that this is something like edge reduction filter. When you apply this, what happens? It slides on this image one step after another. Look here, initially 2x2, right? First it goes to 11.7. It applies this one on top of this one, and then what happens? Each value is getting multiplied with the corresponding 1 into 1 is 1, and 7 into 1 is 7, and 11 into 0 is 0, and 11 into 1 is, sorry, 1 into 1 is 1. Okay, here what happens is, in this case, look here, so 11, right? So yeah, so in this case 11 becomes 0, 9. Look here, so let's take this one only. So 1 into 1 is 1, 7 into 1 is 7, 11 into 0 is 0. Okay, 1 into 1 1. Here 0, right? When you apply this one, so 1 plus 7, how much? 8 plus 1, 9. That is what this one. And second one is, this one gets shifted to the next. See, 7 to 123. Now look at 7 to 123 and slide this on top of this one. Just put this on top of this one. So you take a dot product between each and everything here. Okay, so you can 7 into 1 is 7, 2 into 1 is 2, and 1 into 0 is 0, 23. So 23 plus 25 plus 7, how much? 32. Look here, 32. So it applies, it slides this kernel. It is also called a kernel, filter, LMA, same. Both the names are same. You need to apply this filter on this given image. So first it goes by and then it gets shifted here, and then it goes to the next row, and then it does this one, and it, so for each and every, the kernel needs to be applied for applied on top of your image, and for each and every when it slides, right, each and every time, you need to take a dot product of this one. So initially 11, 7, 11, 1. So you need to 1 into 1 is 1. Look here. So 7 into 1 is 7. So it is something like this here. Just write it. So please concentrate. Look here. I just start with this. And let's say, initially it applies the filter here. Okay. 11 and so 1, 7, 11, 1. Forget about this one at this moment. Look at here, right? This is what you are thinking. First, this kernel got applied on this one. So what is there here? So you have 1, 1 and 0, 1 is there here. So if you multiply this one, right, simply the dot, if you do the linear dot product, what will happen? So 1 into 1 is 1 and 7 into 1 is 7. 11 into 0 is 0, 1 into is 1. So now you need to add all these values. How much you get? That is what you are getting it here. The next one is the filter gets shifted to the next pixel, 71223. 71223. Don't look at here. Okay, whatever I'm writing, look here. So now this filter gets slided on this one, 1101. So what is, if you do the multiplication, what will happen here? 7 into 1 is 7, 2 into 1 is 2, and 1 is 0 is 0, and 23 is 1 is 21. 23 into 1 is 23, right? If you add all these values, you will get 32. That is what you're seeing. The same thing is happening for this one. 11, 1, 2, 2, and 1, 2. It applies it slides this filter, each and every pixel. Okay. That's all. So the output is something. So 9, 32, 14, right? So 9, 32, 14, 26. The output of this one, you will get it as a 2 cross 2 matrix. So your input is 3 cross 3. Your output is 2 cross 2. So now the question is, how do I find out the dimension of my the output, right? This is also called the convolved feature. That means the reduced feature, right? Reduced number of features. So in this case, how do I know? Is there any formula that is available to find out? For example, if somebody is asking you, hey, I have a 3 cross 3 image and 3 cross 3 cross 1. What is 1? 1 is grayscale image. The width is 3 and height is 3. And the grayscale image. So 3 cross 3 cross 1. If I multiply this with 2 cross 2 matrix, what is the output? So is there any formula that is available to tell this one? In this case, it is 2 cross 2, fine. If it is a 3 cross 3, how will you tell? So for that, we have some formula. This is the formula that is dimension of the image. What is the dimension of the image? In the previous case, 3 cross 3. This is what? 3 cross 3, right? And the next dimension of filter, 2 cross 2. What is the dimension here? This is the one I'm talking about, 2 cross 2. And the dimension of output will be, this is the formula that you need to use it. N minus F plus 1, comma, N minus F plus 1. So in this case, what is the N here? 3 minus 2 plus 1. And here, 3 minus 2 plus 1. Both the case same. 3 minus 2 is how much? 1 plus 1 is 2. 3 minus 2 is 1 plus 1 is 2. So hence it is a 2 cross 2 matrix. So what you are saying is correct. This is the formula that we use it to get to know the shape of your output matrix. So now we understood what is a filter. So now the next question is, do I have to use only one filter? You can use multiple filters. We don't use single filter. We use multiple filters. So for each filter, it produces the corresponding output. It is called your feature map. It is also called as a convolved feature. You see, if you apply by default, what we do is, right, 32 features. In general, this is the practice, right? In the input layer, this is my input image. The image is nothing but the array of pixels when it comes to the computer, okay, the systems. So on top of this input image, we're applying the filter to extract the features. We extracted this feature. Okay, so what we do is we use to, right, so typically we start with 32 filters like this, right? You use different filters. There 1, 0, 0, minus 1, minus 1, 0, minus 1, sorry, 0, minus 1, 0, 0, minus 1, something like that. Each filter has some meaning in it. Supposing, let's say this is for finding out the edge, this is for the line, In case of any line, is there how to find out any curve? If you want to find out for that, each and every shape, you have different filters are available. How do I know which filter should I use? You don't have to worry. Just simply specify the number of filters when you define your architecture. It automatically randomly uses the different filters, 32 different filters, and each filters, all these filters are applied on your input image concurrently. This is very important. This is one of the interesting question asked by the previous batch. That is the only batch people were focusing good. They ask, on the fly, they used to ask questions. Okay. See, that's what I'm saying is very simple concept. Concentrate here. Okay, so that is the thing. Okay, 32 filter. Like, see, in this case, I've used only one filter, but the traditionally we use 32 in the conventional layer, right? The input layer, right? So when we define the architecture, the conventional layer, we define 32 for the 32 filters. Each filter will get applied concurrently. All these filters will get applied concurrently. Since we are using 32 filters, each filter will produce one output, right? So 32 feature maps will get produced. Got it? Any confusion? Very simple algorithm. Okay. So usually CNN contains multiple conventional layers. This is what I said. So this is what the picture it shows, right? So here you have conventional and pooling, and conventional and pooling, conventional and pooling. You have multiple conventional. This in the real time scenario, you'll be having multiple conventional layer. Okay, and each conventional layer, the combination of these two will produce the feature maps. So in this case, this is the feature map. This one will be used as an input for the subsequent layer. The first layer captures the low-level features such as edges, color, gradient. The additional layers build on the low-level features based on the the initial features like the edges and color gradient got detected, right? It further identify other shapes, the larger shapes in the image. The next step is the first one will try to find out, like I showed you here. Look here. This is the lady, right? So female, it's a human. Okay. And what happens initially, it finds the edges like this, edges and lines and color, everything. Okay. It finds out that. So what happened when you use the filter, what happens? So look here. After I apply the filter, my dimension got reduced, right? So here it is 2 cross 2, the output. Okay, here it is 3 cross 3. Now it got reduced to 2 cross 2. So that is what is happening here. So that is what the difference. You can see the number of pixels got reduced. Initially, it tries to find out the basic the patterns like edges, the lines, and color, all the things, and the gradient thing. And then what happens is we have something called pooling layer. Pooling layer is helpful to do the downsampling. It further reduce the size of this feature map. Okay, and then what happens is you have something called max pooling and average pooling. How it reduce the size? Using max pooling. You have different types of pooling techniques of max pooling and average pooling. We'll discuss about that little later, okay? And similarly, the same thing is performed by subsequently. So it goes and picks. See, after you use the pool in simple term here, so what happens is the conventional layer, it extracts only the features that are interest to us. All we need is a human or dog or cat. Right? Once with the help of the lines and curves, right, and shape, with that shape, you can tell it's a human or not. Again, still, right, by introducing multiple conventional layers, it picks up this one, it goes and find out the larger features in it, okay? Okay, so it's something like the additional conventional layer build on the low-level features. These are low-level features and identify objects or larger shapes in the image so that it approaches a more human level understanding of an image. Like when we see an image as a human, we can say instantly, hey, this is a human. There is no doubt here. But how the computer knows? It doesn't know. So that's where we use convolutional neural network. Convolutional, what it does is we cannot use neural network, as I said earlier, because it requires a lot of neurons and the training time will be very high and it is not that efficient. Hence, the convolutional neural network, it finds out the patterns since it finds out only the features in it, the size of the image gets reduced to 126 to 126 cross 4. And then here in this case of pooling layer, what happens here is, again, it applies the max pooling. Again, the pixel size got reduced to 63, 63, 4. And then the next one is, again, I'm using another conventional layer. So what happened, based on the low level features, right? It further identify the objects, the objects or the larger shapes in the image, so that it can approach a more human level understanding of the image. That is what you need to understand. So as we have more number of conventional layers, right, what happens is the accuracy will be very high. First, it detects the curve, and the next one is it goes and checks the larger shape, right? So top to bottom, it checks, okay, the shape is something like this. Okay, and even female or male also you can find out. The shape itself it can find out. It goes and each and every layer, it detects the complex patterns. Start with the the very basic level of patterns it will identify, and then as it moves further down the line to the subsequent conversion pooling layer, it identifies the complex features. That is the reason why in the case of deep learning, we will have multiple layers in it. Each layer will perform or identify the complex patterns. So what happens is so that is what now you understood how the conventional layer is working, right? The conventional layer, it uses the filter. We need to specify the filters, how many number of filters, and again the size of the filter, the dimension of the filter is a 3x3 or something else. So see, I told you, so the different filters are used to identify the different patterns from the images. So to identity, whether it is something like camel or something like that, right? So, or the edges 0010, this kernel will use it. It's a 3x3 filter or kernel. These two terms are same. Fine. The edge detection, right? To find out the edge. So detect the edges. Here it goes and checks, this is the edge and this is the edge, and here edge is there, edge is there, edge is there, right? And detect the edges and then sharpen. And then what happens, right? It uses this filter to sharpen it, right? Initially this one, and then it sharpens, and then box blur it, and then Gaussian blur, something like that, right? So, and finally it says, oh, this is a camel, something like that. So each and every layer will find out the complex features in it. As you have more number of layers, the final layer will have the more accurate patterns in it, or near close patterns related to your input image. Okay. And next one is you need to understand what is a stride. Okay, so what is a stride? Stride is the number of pixels shifts over the input matrix. Number of pixels shifts. This is my filter. This is my filter. This is my image. Okay, so what is the size of this image? It is of 5x5, right? 5x5. Let's assume that this is a grayscale. Hence, the value is 1 here. The channel value is 1 here. Okay, and 5x5x1, and we are using this filter. So what happens is this filter slides or the number of pixel shifts over the input. So when you apply this filter, see, you just think, you're applying this one here. Okay, this one and this one and this one. So the 3x3 will get initially applied on this one. So what will happen? 1, 1, 0, 1, 1, 0, 1, 1. And then it shifts over to the input matrix first here, and then next it goes to here, right? So we move, in this case, this is called your filter, right? So we move the filter to 1 pixel at a time. First here, and then next it starts from here. It starts from here, and then it starts from here, and then we move the filter, or we use the term called slide. We slide or move the filter 1 pixel at a time. That is called your stride. If I wanted to jump, right? Let's say if I want to move the filters to 2 pixels at a time, So what you can do is you can specify your argument called stride equal to 2, you can specify. In that case, what will happen is it will apply the filter, this filter here, and then instead of going here, right, it goes here directly. Okay, it is something like moving the filters to 1 pixel at a time. Okay, the stride 1, if you are using the value for the stride as 2, it move the filters to 2 pixels at a time, and so on. Okay, so now you understood what is convolutional layer, what is a filter, and what is a stride. Now you understood. The next one is the ReLU activation function. You remember I discussed about the activation function, sigmoid activation function. In the case of neural network, we discussed about the sigmoid activation function. In the case of hidden layer, it applies the activation function. We have different activation function. I explained about as part of back propagation, I explained about the sigmoid activation function in the hidden layer, right? So hidden layer neuron, the activation function, the sigmoid activation function gets applied on the Z value, and then it produces the output value. So in the case of image processing, typically we use an activation function called ReLU. In the interview, they'll ask you, let's say you have used convolutional neural network. So in the case of convolutional, which activation functions that you have used it? In the case of convolutional layer, I've used ReLU. You tell them. So for non-linearity. Okay, ReLU stands for rectified linear unit. A rectified linear unit. ReLU. Okay, this is called ReLU. This is for linearity because the images are non-linear pattern, right? It is not a linear pattern. It's a non-linear pattern. The linear ReLU, what happens is this activation, what it does is it performs an element-wise operation and replaces all the negative pixel values as 0. Okay, and the next step is and then what happens is whatever the values that are more than 1, it leave it as it is. If I explain you with this, you should be able to understand. For example, this is what my feature map, the convolutional layer. See, the convolutional layer will produce an output, right? After applying the filter. So this is the one I'm talking about, the last one, right? So on top of this, the ReLU activation function will get applied. So let's say the feature map produced by my convolutional layer is something like this. The pixel values are something like this. Okay. The ReLU activation function, what it does is it converts all the negative values as 0. For example, here 0.77, it will leave it as it is. Anything above 0, it will not do anything. Anything less than 0, it will convert as a 0. So that's all. Hence, look here, this one got converted as 0. All the negative values got converted as 0. And that's what I explained to you. In the case of rectified linear units, anything less than 0 will get converted as 0, and anything above 0 will remain as it is. Okay, all the negative values will get replaced by 0 in the case of, because we don't, so there is no negative values in the case of pixel values, right? In the case of pixel value, there is no negative values. So hence, we need to make sure that we have the positive values of your pixels are available as part of a feature map, which was produced by your convolutional layer. So in the case of convolutional layer, it produces the feature map. But on top of the feature map, the ReLU activation function get applied to convert all the negative values into positive. That's all. The next step is we have something else called padding. Okay, and so what is padding? Okay, so this is what we have something called padding equal to same. So this is your input image. For example, in this case, the input image pixel size is 1, 2, 3, 4. Forget about the outside thing. So 4 cross 4. Forget about this one, this layer 0, 0 and all. Okay, forget about this one. Inside this one, you have 4 cross 4. Okay, and so what we do is there are situations we do some kind of padding. So why do we need to do padding? What is padding? You might be asking this one. So when it comes to convolving, as I discussed earlier, right, the image will get shrinked. You remember, the image will get shrink from 3 cross 3 to 2 cross 2. It got shrink. That's why you have to join at the very beginning of the session. This is all important. Look here. Here the very simple concept, right? 3 cross 3, and it got shrink to 2 cross 2. Okay. And if you take a neural network with hundreds of layers on it, right? So it will give us a small image after filtered in the end. In the case of convolutional neural network, okay? See what happens, the input image size was 3 cross 3. After you did the convolution, right? You applied the convolution. The output of the convolution layer got reduced to 2 cross 2. From 3 cross 3 to 2 cross 2, it got reduced. So again, if you pass this as an input to your subsequent convolutional layer, again the image size will get reduced like anything. Since when the image size will get reduced, what will happen? There could be chances you might end up with something information loss. Okay, supposing you need something like the output image should be somewhat same as your input image. In that kind of situation, you can go for padding. You don't want the size to be reduced. So in that case, what we do is when you use padding, so around this 4 cross 4, right? It puts 0, 0. Just around this matrix, it puts 0, 0. The width and height and all, right? It puts 0, 0, 0. Simply, this is called padding here. Simple. The advantage of padding is it can increase the height and width of your output. Just imagine if you have 4 cross 4 and when you apply 2 cross 2 filter, what will happen? Can someone tell me what is the formula here that I used it? Guys, you need to tell fat. Okay. So what is the formula? N minus F plus 1. Right. So here, what is the number of thing here? 4, right? Dimension 4 cross 4. 4 minus filter is 2 plus 1. So 2, 3. So you will end up with 3 cross 3, but I don't want 3 cross 3. But my output should also be same as the dimension of my input. The input dimension is 4 cross 4. So in that kind of situation, you can go for padding. Because what will happen is, right, the image will get shrinked when you have multiple convolutional and pooling layer. In that case, what will happen is you might tend to lose certain things. And if there is a requirement, something like, you need have the output image size same as your input size. In that kind of situation, you can go for this one. Other thing is, in the pixel in the corner will only get covers one time. If you take the middle pixel, it will get covered more than once. Okay. See, so the disadvantage of this one, right? Without using padding, the conventional layer, the disadvantage of the conventional layer is it shrinks the output from 4 cross 4. Here it is 4 cross 4. It shrinks to 3 cross 3. Right, 3 cross 3. Since we did the padding, we put 0, 0, 0 around this matrix. Now the output size also same as the input size. Now it is 4 cross 4. But if you don't do the padding, your the output, the output will, the image will get shrink 3 cross 2, 3 cross 3. So in that case, what if this gets shrinked, what will happen? You will lose the information on the corners of the image. See what happens is when you apply the filter, first this filter will get applied here, and then straight it will come here, and then it will come here, and then when it comes here in the corner, right, you don't have any perfect match here. You don't have any perfect match here. So here 2 cross 2, the 1 0 will get applied. The 0.5 into 1 will get multiplied, 0 and 0. It is the filter. When you slide the filter over the pixels one at a time, what happens is, in this case, it does the dot product. 0.5 into 1 is your, so that, right, it multiplies each and every. 0.5 into 1 is 0.5, 0 into 0 is 0, 0 into 0 is 0, 0 into 0.5. So you are end up with 0.5. So if you add all these values, after you do the dot product with your filter value, you will get 0.5 only. Look here, 0.5. So, or maybe, right, so 1, 2, 3, and the fourth one. Fourth one, in this case, just we are getting 0.25. Okay, because here 0.5 into 1 is 0.5 and 0 is 0, and you don't have the picture perfect value here, right? So you cannot apply this here. So what happens is you will lose information on the corners of the image because you cannot apply the filter for, in this case, right? It is not a picture perfect one, the filter. When it comes to the corner, it cannot find the additional dimension here, right? So it is just 1 cross 1, 2 cross 2 is not there. Okay, that confusion will happen. So in that kind of situation, the padding is important. The one reason is if you want the output, this output should also be same as your input image size, then you can go for padding. The other reason why we are using padding is the interview they'll ask you. The other reason is you will lose the important information that are there in your corners of your image. In that kind of, we don't want to lose the important information that are part of the corner of my image. For example, in your image, you have something called a person is standing here, right? Your filter will capture this one. Let's say here you have something else is there. Since it is not picture perfect, the filter here, right? What will happen? You are losing this information here. So in that kind of situation also, you can go for padding. So we discussed about the convolutional layer, and then we discussed about filters. And as you know, filters, different types of filters are available for extracting different patterns. And by applying the filter is also called as a kernel. By applying the filter on your input image, and if you use the stride, but the default the stride is 1, it move the pixel 1 at a time. First it will apply the filter here, this one, okay, 1 0, and then it moves 1 at a time, and then it moves here. Let's start with this one. Once again I repeat this filter will get applied on this one. That means you just think this, if I keep this, if I take this and I keep it on top of this, how it will be, right? That is how it happens. The filter is applying in the sense this one will be lifted and kept it on top of this one, and then it does the dot product. So 1 and 1 will get multiplied, and 0 0 will get multiplied. 0 0 is 0, 1 is 1 into 1 is 1. So 1 plus 0 is 1, and 0 is 0, right? So 1 plus 0, so 1 only. And 0.5 into 0.5, how much you'll get? So 0.5 into 0.5, 0.25, right? 2.25 plus your 1, so 1.25, you will get 1.25, something like that. Okay, 1.25, it will apply the filter, and then it gives us. In this case I did the padding. So in this case what happens, it goes by this one. Okay, 0 0 0 1 1 1 0 is 0, 0 is 0. So first row will become 0, and second row also this one. 0.5 into 1 is 0.5. That is what you can see it here. Okay, that is what you are seeing here. After we did the padding, when you apply the filter, this is the one. Before you do the padding, so you will get something like 1.25. This is how the filter. So we discussed about the conventional layer and the filter. By applying the filter on the conventional, this is called convolving operation, which is nothing but applying the filter on your input image, and then you will get the output. When you apply the filter on the input, you will get the output, right? This is called your feature map. In simple term, you are reducing your input matrix dimension. Okay, and your output will be reduced matrix dimension, which is nothing but the pixel values. Okay, and this pixel values, you will pass it as an input to your subsequent convolutional layer. So further, there you are using another filter. That filter will get applied on top of this one. So by doing so, by using multiple convolutional layer, we are trying to extract the most relevant features. The relevant features will be passed to your fully connected layer. So what is padding? Now you understood, right? If you want the output image size or same as the input image, that kind of situation, you can use it. You can use padding. The stride is nothing but moving the pixels one at a time when you apply the filter, or when you slide the filter on the input image. Apply, slide, both the terms are same. Okay. Zero padding allows us to preserve the spatial size of the input image. Okay. And the next one is conventional layer padding. Here I explained it. Look here, the map of one complete filters 3. In this case, this is my input image, and 3 filters we are using it. In this, like I said earlier, in the case of conventional layer, We can use more than one filter also, but in reality, we'll be using multiple filters on your, we will be applying the multiple filters on your input image. Okay. So here, what is my filter size? This is my filter, 3 cross 3. Here also 3 cross 3, 3 cross 3. Okay. And here, how many number of filters we are using it? 3 filters. Number of filters are 3. This is 1, 2, and 3. Each filter size is 3 cross 3. That is what it says. Stride is 1. So moving by, when you apply this one, what will happen? 3 cross 3 will get, this one will get applied first here. Since stride is 1, the filter will get moved one at a time. Okay, and here, and then next it will get moved here, and then it does the dot product for each and every time. Okay. A conclusion, input image is 9 cross 9. In this case, output of convolution is 7 cross 7 cross 3. So red, blue, green, right? If it is a color channel, this is how it works. So in this case, what happens in each and every filter, right? It produces the corresponding, the output, feature output map. So if you see here, 7 cross, this is your 9 cross 9. This is a 7 cross 7. So 3, 7, because since you are applying 3 filters, 7 cross 7 feature maps will get created. Next, pooling layer. What is pooling layer? So far, we discussed about the input layer, the convolutional layer, and the convolutional layer produces the feature maps. Okay, the convolved feature output. After applying the filter, you get the output, right? That is what your feature maps. So, and on top of the feature maps, pooling will get applied. So now we will take a look at what exactly pooling. So far we did not discuss about the pooling. Pooling layer, in this case, right? The purpose of the pooling layer is to reduce the number of parameters when the images are too large. This is something called spatial pooling. It is also called as subsampling or downsampling. Basically, we are taking the feature maps, okay, and then we apply the pooling on this one. We are trying to reduce the size of this one further in simple term, okay. But if you don't apply the pooling, what will happen is, let's say in this case, right, you are using 32 filters, 32 feature maps will get reduced, and each feature map will be like 126 cross 126. So all 32 into this much, it will be very big one. When you apply the pooling on this size will get reduced. In simple term, that is what is happening here. There are two types of pooling. One is max pooling and average pooling. Look here, this is what, let's say this is the output produced by your convolutional layer. So let's say this is the one. I'm talking about this stage, okay? Before applying the pooling, your pixel size is something like this. Your matrix is something like here. How much you have? 4 cross 4. 4 cross 4. And if I use max pooling, what happens is, and the max pooling is, 2 cross 2, right? So what happens is here, it takes the first one, right? So in this, which one is maximum value? Anybody can tell. Of these 4 values, which one is maximum? Which one is the bigger value? Jivanandam, you can tell, right? Jivanandam is not there. Okay, is there. Oh, yeah. Of these 4 values, which one is bigger here? 20, right? It will take the 20 here. See, now it is applying the pooling on the output produced by my convolution, okay, convolution layer. So what happens is I'm applying the max pooling in this case. The maximum value is 20 here. Here I'm using 2 cross 2, max pooling 2 cross 2. You can use 3 cross 3 also. And the next one is it shifts to here. When it comes here, which one is the maximum value? 30. So of these 4, right, 30 is the maximum, here 20. And of these 4, 112 is the maximum value. Of these 4, 37 is the maximum. Instead of using max pooling, you can do average pooling also. Now these 4 values, what is the average? 30. For this, I think 32 divided by 4, 8, right? Average. Instead of taking the maximum values, we are getting the average. You can use either max pooling or average pooling. Okay, the max pooling is the one is used in few of the projects where I worked, right? So we have used max pool. So in this case, the pooling is a 2 cross 2 filter. That is what I mean, 2 cross 2 filter. And here stride is 2. Look here, not one here. So first you apply the 2x2 filter, and then instead of moving the filter one at a time, move two at a time. So don't start from here. Instead, you start from here and apply the 2x2. Stride equal to 2, and the filter is 2x2. Right? So this is what we get it. Max pulling. In the case of orange pulling, we get this one. So now my output got reduced further. From 4x4 to 2x2, it got reduced. And then what happens is the next step is, now we will go back to the architecture. This is the layers. You have the input layer, you have the conventional layer, and you have pooling layer. Pooling layer downsamples your feature maps which were produced by your conventional layer, right? So you apply the filter on the input image. That is called your convolutional process. And then the convolutional process will produce in feature maps. On top of that, when you apply either the max pooling or average pooling, your size of your in the pixel, right, the matrix will get reduced further. And then if you have additional conventional pooling layer, it picks up this value, in this case, in this example, 2x2, and then that one on top of that, again the filter will get applied. Okay, and again you apply the pooling, max pooling. Okay, so what will happen is, in this case, the size will get reduced as it moves further down in the layer. The size will get reduced. The output from the conventional layer was 2D matrix. Okay, the fully connected can only work with one-dimensional data. Remember this. Why do we need to flatten the output produced by your conventional and pooling layer? Because the fully connected, the typical neural network can only work with the one-dimensional data, not the multi-dimensional data. So in this case, what happens is, so for your sake, when I put the comment here, the value generated from the previous operation or first converted one. So this is, let's say this is my, after applying the max pooling, this is what I'm getting it. So you have the conventional layer, and then you have the max pooling layer. The pooling layer output is like this. It's a two-dimensional one. You need to convert this a single dimension. So you need to flatten this. When you flatten this, what will happen? 9, 32, everything will be 1x1. You have 1x1. So in this case, the feature map matrix, this is what I'm talking about. The feature map matrix will be converted as vectors like this. With the fully connected, we combine these features together to create a model. Finally, we have an activation function such as softmax. This is very much important. So in the case of conventional layer, we have used a ReLU activation function, rectified linear unit. So what it did, it converted the negative values to 0, and any value above 0, it left as it is. Because pixel values should range between 0 to 255. It should not be negative values. So for that purpose, in the case of convolutional layer, a ReLU activation function was used. When it comes to fully connected layer, right, in the output layer will, the softmax activation function. Forget about this one, softmax. For softmax activation, what it does is, it converts these pixel values, or it classifies these values as cat, dog, or something like that. Okay, with the probabilities, it will assign the probabilistic value, like I have shown you here. Look here, this one, the fully connected layer. In the case of classification, what happened? It flattened this feature map, okay, into a vectors, one dimensional. And then this one is used as an input neuron layer values, and then the output layer, we are using the softmax activation function. What it does is, it converts this one into probabilistic value. Like a cat is, it assigns the cat class as 0.05 in this case. Okay, dog as 0.10. This is the probability. Whichever class, cat, dog, horse, of these 4 class, which class has higher probabilistic value? This one. Hence, the convolutional neural network will produce an output saying that the given input is a human image. That's it, guys. This is how it works. To summarize, we provided the input image into our convolutional layer, and then we chose parameters and then applied filters with strides, and you can do padding if required and perform convolution on the image and apply ReLo activation function to the matrix and perform pooling to reduce the dimensionality size, add as many convolutional layers until it is satisfied and flatten the output and feed into the fully connected layer. The output the class using an activation function and classifies the images. In this case, in the case of output layer, we have used something called softmax activation function, whereas in the case of conventional layer, we have used a ReLo, rectified relay, the thing. Okay. So hope you understood with this session what exactly convolutional neural network is all about and the role of convolutional layer. You have understood very clearly. Also, you understood what is filter is all about, what is ReLo is all about, and what is pooling layer is all about, and why do we need to have more than one conventional and pooling layers. You understood, and yeah, and then in the case of fully connected layer, right? So why do we need to convert the feature map produced over the previous pooling layer, right? The feature maps needs to be converted as a one-dimensional. We need to flatten this. And why do we need to? Because fully connected layer will work only with the one-dimensional one-dimensional data. It cannot work with multi-dimensional data. For that purpose, we are converted. Hope you understood each and every pieces of this architecture, the role of each and every piece of this architecture. I explained you piecemeal by piecemeal what each layer does. Okay. Next one is the demonstration. Okay, how to implement them in that will take quite a time. Okay, it will take another half an hour time. What we will do is we will continue the next week. Next week we'll spend more time. We'll try to cover the support vector, everything. What are the leftover thing? We'll finish it up next week. And today some festival is there.